Yeah, Yeah, guys. So statistics is very simple, right? We have basically four objectives when it comes to statistics. It's to collect, organize, summarize, and represent data. So this is what we're going to do for the rest of the year. When you come to these live lessons, I'm going to be explaining everything that you need to know, right? But obviously, it's impossible for you to listen and write in 1 hour 30 minutes. It's impossible. And so this is why you'll have to go back, watch these videos, and take down the notes. Right? Could you come to the lessons, not take down the notes, and still succeed? Yes, it's possible. But do what's important to you and get all of your notes in order, because these things you're going to revisit these things over and over. So if you have all of your notes in order, when we look at 3 or 4 years down the line, these things will just be child's play for you, right? So you don't go scrabbling around for information. So I want you to basically do the right thing the first time around. Okay, so let's talk about statistics. So statistics is a study of collecting, organizing, summarizing, and representing data. So if you have someone going out and like serving a group of people, that would be an example of collecting data, right? But then we need to take all of this chaotic piece of information and organize it in a way that we can, extract useful insight from it. So that's where we talk about organizing. Summarizing would basically be drawing conclusions from that organized data, and representing it would be exactly like what we're doing with functions. What are we doing with functions? We're trying to attach a visual to these numbers. Do you all understand? So it's like basically saying that I have these numbers, it's abstract, I need to understand it, let me represent it visually. And so when I started the trigonometric functions module, this is the way I put it. When we did algebra, I spoke about what? The linear, parabolic, hyperbolic, and exponential function. I said these are numbers. This is the way we understand them, right? This is how we understand it visually. When we talk about trigonometry, in trigonometry, we talk about what? Sine, cos, and tan. How do we see this visually? We use what we call trigonometric functions. When we talked about geometry, how did we understand it visually? We use what? Polygons, circles, triangles, squares, and so on. So it's not just numbers and words. We're seeing these things visually. Now, when we talk about stats, we will represent it using a whole host of tools like histograms, frequency polygons, stem and leaf plots, and so on. Right? But when we get there, you'll see what I mean. But what I'm saying is, this is the division that we need to think about. I have these numbers. These numbers are trying to communicate something with me. This is how we see them visually, right? If you can have this insight where I can see the numbers and I can see it visually, trust me, that will be a walk in the park. And so any problem you're given, if you can translate it visually, then you'll understand maths at the highest level, is basically what I'm saying. Okay. So yeah, that's basically what we're doing. So four objectives. Four objectives: collecting, organizing, summarizing, and representing. Whenever you're doing stats, it's the four things you need to think about. Stats is not difficult. The reason students lose marks in stats is because they don't understand definitions well enough. So they take it lightly. They think it's a very simple topic. It is, but if you don't understand your definitions and what you're doing, you'll never understand statistics properly. If data is so important, then we should define and classify it. So what's the basic idea, the foundational idea here is using data. So we have to understand what it is. Data is broken down into two categories, what we call qualitative data and quantitative data. Qualitative data basically describes a subject. It uses words. Quantitative data basically uses numbers. So we quantify, we're making use of numbers. And then quantitative data itself can be broken down into discrete and continuous. Discrete meaning integers like my 1, 2, 3, 4, 5, and continuous meaning real values, like your fractional values. Right, you can see all these. This comes from number systems, integers and real values. Discrete and continuous comes from where? From functions. Remember, we spoke about discrete functions and continuous functions. It's the exact same idea. So again, we're starting off with data, then we're talking about qualitative, right, and quantitative. Right, qualitative and quantitative. And then under quantitative, we broke it down into discrete and continuous. So discrete is basically like you're counting, right? There's 10 pencils on the table. That's discrete, right? It's not fractional values where you basically have comma something, right? And continuous is where you have a whole number part, a decimal, and a fractional part. Okay, so basically decimals. Okay, let's take examples of this. Qualitative data would be interviewing 50 people about their preferred pet, and that's, can you see, it's describing the subject, right? We're using words. That's how we call it qualitative. Quantitative data will be interviewing 50 people about the distance they travel daily. Right? You can't actually travel 50 kilometers daily. It'll always be comma something. Okay? And so if you put that data down, that's what we call continuous quantitative data. Right? But these values here, 50, 16, 60, 40, and 200 will be an example of discrete quantitative data. But obviously, we can't use that here because we're talking about a distance, right? It can never be like a rounded off amount. Very unlikely. But then what we do is with qualitative data to make it more useful, because you can't do, what can you do with this? Think about it. What can you do with this? You can't really do much. If I need to organize this, what I'm going to say, what could I possibly say? I could say that the number of people out of this 15 that like cats were 4. The number of people out of these 15 people that like dogs were 5, and so on. And so what we did now, we basically converted qualitative data to quantitative data. And so once we have these numbers, now we can do so many things with it. Right? We can apply some of the techniques that we will learn under statistics. So yeah, that's basically it. So going from qualitative to quantitative, we can basically draw useful information from this. So qualitative data on its own is not very useful, other than just describing the subject. Okay. Right, so that is statistics. Again, can you see that I'm taking the definition? There's a nice diagram here to categorize it. We're collecting, organizing, summarizing, and representing data. And we do that repeatedly. Right, so that's what we call statistics. Collecting, organizing, summarizing, and representing. Now we will talk about a branch of statistics. Now, statistics is a very big topic, but we're going to talk about a branch of it. So there could be another arrow here, and it could talk about some other topic that we don't even care about. We're just focusing on just this one branch, which is called descriptive statistics, right? Descriptive statistics is a branch of statistics that focuses on organizing, summarizing, and representing data in a meaningful way. So out of these 4 objectives, we use what we call descriptive statistics to organize, summarize, and represent. Okay? For example, if you survey a group of students about their test scores, you good there, Samesh?
Yeah, sorry.
Okay, Lily. Yeah. If you survey a group of students about their test scores, descriptive statistics can help summarize the average score, the most common score, and how widely scores vary. So the most common descriptive statistics focuses on determining the average. So these are terms that you would have come across before: mean, median, and mode. We did this at grade 8 and grade 9. Right, so like a branch of descriptive statistics helps you find these values here. Okay, so this shouldn't be foreign to you now. We've already done that. Okay, now let's talk about delve deeper. So we started from here now. We're going deeper. We're going to descriptive statistics. Now from descriptive statistics, we're going to go even a layer deeper. And what are we going to do? We're going to focus on 3 parts: frequency distribution, measures of central tendencies, and measures of dispersion. Remember, again, these are just techniques. These are like principles that we can use. Okay? So again, under descriptive statistics, we're focusing on what we call frequency distribution, measures of central tendencies, and measures of dispersion. And what these 3 things are going to help us do, it's going to help us organize, summarize, and represent the data. Right, so you have a piece of paper. You have people's answers on it, right? How are you going to organize, summarize, and represent this data? Using descriptive statistics, right? And what do we do under descriptive statistics is these 3 topics. So can you see, right? We're going and we're branching out now. For frequency distribution, we use it for 2 things. We use it for organizing and representing the data. So if you look here, out of the 2 core purposes of statistics, frequency distribution helps us to do 2 things. It helps us to organize the data and represent it. And then the measures of central tendencies and measures of variability helps us to summarize the data. Okay, the collection of it we're not worried about, because Why we're not too concerned about the collection? Because it will be given to us. So our only purpose is to organize, summarize, and represent. Okay, yes. So that's that. Under frequency distribution, we're going to use tools from there. Under measures of central tendency, this is what you remember now. You should remember this: mean, median, and mode. Mean is basically the average. Median is the middle value. Mode is the most frequently occurring value. Right. So those terms come from this big topic called central measures of central tendency. And then lastly, your measures of dispersion. It shows you how spread out the data is. So this is what we call range and the 5-number summary, which is we'll deal with quartiles and so on. So don't worry about that too much. The main thing that you need to take from here now is these 3 main topics that we're going to work with. Okay. So yeah, this is the basic overview: measures of central tendency, measure of dispersion, frequency distribution, and something that we will do at grade 12 called correlation and regression analysis. Just a big overview there. Right, now let's zoom in on each of this. So we're going to zoom in on this one here, and we're going to understand exactly what is frequency distribution about. So remember, we said it helps us to do 2 things: organize and represent data. And so basically, it's there to show you how often each value or a range of value occurs. So I have a sheet, right, with people's answers on it. We need to organize it. We need to put it in a useful way that we can read from. And so what do? We make use of stem and leaf plots, which is here, frequency tables, which is here, or tally tables, which is here as well. Can you see that? And so that's basically what we do. It's like we're zooming out to see, like if I have to zoom in here, how many size 1s do we have? We have 7 in the data set. How many size 2s do we have? 13. How many size 3s? 3. How many size 4? 2. Can you see that? So we're zooming out on me, categorizing it. Let's see here, look at this one here. Marks scored by students. How many students scored between 41 and 49? 3. Number of students scored between 50 and 58? 6. 59 and 67? 5. Right? The amount of money spent on whatever we analyzing, between 0 and 10 rand, 1. Between 10 and 20 rand, 2. Between 20 and 37. So that's basically what frequency distribution does, is it enables us to categorize this information so we can look at it much more clearly, right? And yeah, this is basically what it organizes raw data into a structured format, often in a table or a graph, right? It helps identify patterns, trends, and outliers, and it can be grouped or ungrouped. So see these 2 examples here is what we call grouped data, because we're putting them in intervals. We're saying between 41 and 49, how many students scored that mark is 3, right? So as opposed to, let's say that we have 20 different students, as opposed to having 41, 42, 43, 44, 45, and say, okay, 1, 1, 1, 1. We're saying let's put it in an interval and group it up so that it's much more convenient to work with. Okay, but don't worry about that. I'm going to get into much more depth about how we go about doing this. But for now, all you need to know is frequency distribution helps organize raw data. And how it does that is one of these 4. Right, so this is what you're going to need to know eventually. I'm going to show you the how when we get there. Okay? Measures of central tendency. It helps you to identify the typical or the central value in a data set. Right. It tells you where the center of the data lies, like the average test scores. The common measures that come under here is what? Mean, median, and mode. And it helps you summarize a large data set with a single representative value. And so the way I think about this here is that if let's say you step into a classroom and I want to say, okay, what's that one number that you can give to this classroom that will tell you the way everyone performs, right? What's that single value that would represent that classroom? So that's how you would say, okay, sum the number of marks and divide it by the number of students that are in the class, and the number that you get will tell you what's the general idea or the general trend in that classroom. Right? And so if you walk in a classroom and say, okay, classroom A is a 50% average on average. So most of the students score around 50%. Some less, some more. But the general, most of them score 50%. Right? If I go into another classroom and I see that classroom is a 90% performance classroom, then I would say, okay, a lot of students, it's a high performing classroom. Then we'll say, that's an A plus classroom. Right? So what's that one value that one value, that one representative value that would give you or summarize the entire large data set. That's basically what we talk about with measures of central tendency. When we talk about measures of dispersion, it tells you how spread out the data is around the center, right? It shows you whether the data points are tightly packed together or widely scattered. Now, basically here what we're doing is, let's say that I had this number line here, and this went from 0 to 100%, right? And this is 50%. And then I plotted all of the marks. So let's say someone scored 13%, I'll put that mark there. Someone scored 25%, I'll put it there. And I did that. What measures of dispersion shows is how far apart are these marks from each other. Can you see that? How far apart are these marks from each other? Because what could happen is, I could have a 90%, I could have a class, a 90% class, a class that performs, a high performing class. But what could happen is that the data set, so the values relative to each other will be spread out. And so what we're saying is that there's not much consistency or reliability, right? So the teacher in the classroom is only speaking to a select few people. His way of teaching is not resonating with everyone, right? So here we focus on what's the general trend. Here we're saying, okay, how consistent is the data? Because if all the marks were closely packed, compare this to this here, 0 to 100%, right? And let's say that all the marks were like this here. If I plotted all the marks, it did this. And it was, let's say this here is 50%. If all the marks were closely packed, we can say that this is more consistent as opposed to this. This can't be reliable because everyone's marks is just scattered from 0 to 100. Here you can see that majority or almost all of them scored around that 50%. Can you see that? And so here we're talking about the general trend, and here we're talking about the reliability and the consistency of the data. Okay? Again, if you don't understand this, I just want you to remember these keywords. This is to represent. Measures of central tendency is to give you a general idea of what the data is telling you. And here's this measures of dispersion is to tell you what's the reliability of the data. And so there's a nice idea here. Let's say that you got two classes, classroom A and classroom B. And this is the marks from classroom A, and these are the marks from classroom B. When you find the average, right? When you find the average, both gives you 5. So how do you find the average? Add all of these values up and divide by 5. Both will give you 5. And so you would say, okay, both these classrooms perform more or less the same, isn't it? And the answer is no. Because we can see here that the data here are spread very inconsistently. You can see this basically, let me show you. This here basically represents this visually, this one here. And this one here on this number line is represented visually here. This and this. Can you see that? So this is more consistent because a lot of people are scoring around 5. But yes, how many people scored around 5? Only 1. Here, 3 people scored around 5. So this is how misleading measures of central tendency can become. Because it says that both are 50, let's say 5 or 50% classrooms. But this one here, the marks are spread very unreliably, right? So you can't really say that it's a 5 classroom. It's actually lower because we have a lot of low performing students. Here we have fewer low performing students, right? So that's what the dispersion does. When you look at all of these, if you look at each of these data points, how are they spread out? If it's spread wide apart, very inconsistent. If it's closely packed together, very consistent, right? And then we'll have numbers assigned to this to help us understand these things. Okay, so that's what all of these things tell us. This is showing us or organizing the data. Measures of central tendency help us to get a general idea of the data set. Right? What's the general idea? What's that one value that would represent the entire data set? And the measures of dispersion tells us how consistent is the data. Because two data sets could have the same representative value. See, both have the same mean. But when you look at how far apart each data point is spread from each other, this one is spread out further than this. And so what we can say is that teacher A has more consistent results than teacher B. More reliable, less reliable. More reliable, less reliable. Right? More consistent, less consistent. So where the measures of central tendencies lack, the measures of dispersion makes up for it. Because you can have the same mean. This proves it. You can have the same mean, but without the measures of dispersion, you can't really say which is more consistent. Right? Having the same mean doesn't mean that they perform the same. These two classes don't perform the same. Think about it. If I just said, what's the general trend of the data set and both gave me 5, can we say that both these classes perform the same? We can't, right? We need to use measures of dispersion, which makes use of what we call range and standard deviation to understand that. And when you do that, because you see that these values are tightly packed together, you can say that this is more consistent. So this overall, in my opinion, is a better classroom because it's more consistent and reliable. Here, the teacher, it's just further apart, so you can't really say it's consistent. Okay, so yeah, I hope you guys, is everyone catching on? Delaney, are you understanding? Sumesh?
Yes.
Delan?
Yes.
Okay, perfect. Like guys, trust me, it's not as complicated as this, but like I said at the beginning, your definitions are extremely important. You're going to get caught out with definitions here. And this is 3 marks in the paper, so make sure you get it right once. Okay, and lastly, so remember, let's go back here to the top. What did I talk about? Organizing, summarizing. Now we have to represent this data, isn't it? So how do we represent it? Again, using frequency distribution. All right, how do we represent it? There, using a histogram, I'll show you how to draw this, or frequency polygons. Again, I will show you how we draw that. Right, but that's basically what we do. Yeah. So now we did a lot of talking. Let's put all of this into perspective. Right, let's put all of this into perspective. So I'm not going to talk about the definitions. I just want to give you a quick example, and so you can understand, get a more anchored way of understanding what these things are saying to us. Right, a teacher records the scores out of 100 for 20 students. So students wrote an exam, the teacher marked the exam. These were the marks out of for 20 students. Right, there's it here. I need to take this data and I need to organize it. So remember, organize, summarize, represent, and collect. That's the only 4 things we're doing. Okay, the collection, there's it here. It's given to you, so we don't have to even worry about it. So let's talk about frequency distribution. Because we're dealing with 20 different data points, it does not make sense for me to go and put each one on a row. Do you understand? That's why we talk about grouping data, something that I will explain now. Right? It does not make sense for us to just put them on each row given a mark. Does not make sense. So this is why we put them in ranges. It's a rule that we use. So to organize large data sets, we put them into ranges or into groups. So we have the 50 to 59 group, we have the 60 to 69, 70 to 79, 80 to 89, 90 to 100. You can do this as long as you have intervals that will cover the entire data set, right? So between 50 and 59, 1 person scored there. There's it here. Between 60 to 69, 5, and so on. So you count the number of values that fall in these categories and you write them down here. Right? That's simple. If you add all of these values up, what should it give you? Must give you 20. Right? It must give you 20. And so what we can say is that the frequency table reveals the overall shape of or distribution of the data. So we can see and organize the data much more neatly. So can you see here? Look at this. Can you see around that 60 to 90? Around the 60 to 90. Most of the students scored around 60 to 90. Can you see that? So this is what we can see. Here you can't see it, but now you can see it here in this table. Measures of central tendency. 3 things that we talked about there. Mean, median, and mode. What does measures of central tendency do? They help us summarize data, and that one word that can help you think about it is what's the general trend, right? And so when we find out the mean, add all of these values up and divide by 20. That gives you 77. So what is that one value that would represent this entire data set? It would be 77%. So we can say that most students scored around 77%. What's the middle value, the median? How do you get that? Is you count, right? But I'll show you the technique. But for now, you basically just count. Let's just think of it like that. So you count, because we have 20 points, you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it'll be around the middle there, right? But don't worry, I'm going to get a bit more tactical about it. but the median is 75%. So I'll tell you what that means just now, right? Don't worry. The mode, what is the most frequently occurring marks? 60, 65, and 75. So if you come here, can you see 60 is twice, 75 is twice, and what is the other one? 65 as well. Yeah, 65. So 60, 65, and 75. All right, so we can see that many students scored that same mark. So that's literally all you're going to do. And so what these values tell us is basically what's the typical performance of the class. Right, the mean tells you the teacher, the class average. The median shows you the central scores. Don't worry about this here. And the mode highlights the most common scores. Literally. So if you had a paper, they tell you find the mean, add all the values up, divide by the number of data values that there are in the set. Okay. What it tells you is what's the general trend in the class. It's 77%. Median is the middle value. Mode is the one that occurs the most frequent. Then we move on to something called range. Range is basically your highest value minus your lowest value, and you get an answer, which is 43. And yeah, and then we move over to something called quartiles. So let me just give you the values for this. Quartile 2 is 75%. It's the same as the median. Quartile 1 is 65% yeah, which is something that I will show you. And then we have quartile 3, which is 86%, 86.5. Now, you know what this does, what quartiles do. It basically breaks this whole entire data set into 25% increments, like this here, right? It breaks it up into 1 quarter, 2 quarter, 3 quarter, and 4 parts. Now, this is what we mean by quartile, quarters. So take this 20 and divide it by 4. It gives you 5. So every 5, you're going to have something happen, right? We're going to have a mark. And what this does, listen to this is very powerful. When I said quartile 1 is 65, I said quartile 1 is 65, it's here. It tells us something very quickly, right? It tells us this here. It says that 25% of students scored below 65%, right? And 75% scored 65% and above. Quick ways of analyzing data. When I said that quartile 2 is 75, so it's 75, it means that 50% of the students scored less than 75 and 50% scored 75% and above. Quick ways of analyzing data. If I said that the quartile 3 is 86.5%, then that means that 75% of students scored less than 86.5 and 25% of students scored 86.5% and above, right? It's just quick ways of analyzing data, right? And think about it. If you want just quick summaries of what the data is telling you and how everything is distributed, this is what the measures of dispersion would do, right? Because if you think about it, if I had, let's say the quartile 3 was like 92%, it was somewhere here, then I can say that 25% of the students scored above 92%, which is quite decent if you ask me, right? It's quite decent. That means that 4 students out of the 20, because we're saying 25% of 20 is, sorry, 5 students scored above 92%. That means that the class is performing quite well. Okay, so that's what we're trying to see from this data. Think about it. If quartile 2 was, let's say, 92%, quartile 2, right? That means that 50% scored less than 92%, but the other 50 scored what? Above 92%. That means 10 students scored above 90%, 92%, right? That's 50% of the class. That's excellent, right? So this is what we're trying to see. And now you can adapt, you can use the same idea and change it and adapt it in a business sense when you're talking about people's heights, and whatever the scenario is, that's basically what we're learning. So yeah, and then yeah, that's basically it. I don't want to get too much into this here because this here requires a lot of understanding about quartiles. So that's basically it, an overview of measures of central tendencies and measures of dispersion. Just a quick idea. Now let's go and get a bit more tactical. Let's learn the how now. Let's learn the how. How do we organize data, right? And then how do we summarize it? And how do we represent it? That's basically what we're going to learn Now, again, we said the organization of data comes from where? Frequency distributions. Right, so there's three things: frequency distributions, measures of central tendencies, and measures of dispersion. Frequency distributions is going to help us to organize data. Now we're going to learn how we do that. You can organize data using tallies, frequency tables, stem and leaf diagrams, histograms, and frequency polygons, right? We can also group data into intervals, right? And this is going to be very important. So let's talk about grouping data. This falls under the organization of it. A practical approach to organize continuous quantitative data is to divide the entire range into distinct intervals or classes. Since continuous values, such as height or weight, can take on infinitely many possibilities or often don't repeat exactly, it's more meaningful to group them into intervals that capture where each value belongs, rather than listing them individually. Think about this. If I had continuous quantitative data, like 150.1, 150,135, 150,25, to take this here and give each line, right? Each line, I'm going to put these numbers and then say how many people have heights of 150.1, how many people have heights of 150,135 would be very burdensome, right? It's very impractical to do so. And so this is why we group them. Instead of saying, okay, 150,1 and the number of people that belong to that value, we say, okay, between 150 and 160, how many height values belong to this category? This is why we categorize data, okay? But we have to make sure we do something, which is the process involves defining non-overlapping intervals. So they must not overlap, okay? So if you're saying that this interval starts from 150 and ends at 160, the next interval must start at 161 and end at 170. The next interval must start at 171 and end at 180, right? Okay, guys, log out and join back in, please.